Welcome to another episode of Terry's Notes, and this is our second video on electrolysis. Now, there are basically three factors that determine which ions are discharged during electrolysis. The first one is the position in the electrochemical series. The lower down an ion is in the electrochemical series, the more likely it will be discharged from solution. The second factor is the relative concentration of the ions in solution. The greater the concentration of an ion, the more likely will it be discharged from solution. And the third factor is the nature of the electrode. If the electrode is not inert, it will affect what takes place during electrolysis. This is the electrochemical series. So if we have a solution containing different ions, the one lower down, right? So the ones lower down will be discharged first. So if you have a solution containing copper and let's say sodium, copper will be discharged first. If we have sodium and H+ ions, hydrogen will be discharged first. So the ones lower down are discharged in preference to the ones higher above. Our first example is the electrolysis of molten lead-2 bromide. And this is the diagram for the electrolysis. Notice we have the lead-2 bromide here. And notice we have to heat the lead-2 bromide. The reason for heating is that the lead-2 bromide is a salt initially, and if we heat it, we need to melt it. When it's melted, the ions become mobile, and therefore what will happen is that you have movement within the liquid so that an electric current can flow. Okay, this is a typical examination question. Once you heat the lead-2 bromide, the ions become mobile. Okay, now the ions present in lead-2 bromide are Pb2+ and Br-. At the anode, we expect the negative ions, in this case the Br-, to move towards the anode, and the half equation for this reaction is that 2 Br- minus 2 electrons produces Br2. At the cathode, we expect the cations to move towards it. In this case, we are talking about the Pb2+. So the half equation is 2 Pb2+ plus 2 electrons producing Pb. So therefore lead is being deposited at the cathode and bromine vapor is seen at the anode. In this case, we have the electrolysis of sulfuric acid, and the ions we have present in the sulfuric acid are H+ ions and SO4 2- ions, and from the water we have H+ and OH-. Okay, this is a typical diagram. Notice we have test tubes to collect the gases being produced in this scenario. So now we know that the anode is the positive electrode and the cathode is the negative electrode. So at the anode we will expect the OH- and the SO4 2- to move towards it, but which one will be discharged? In this case, we have dilute sulfuric acid, so the OH- is the one that is going to be discharged, and the half equation is 4 OH- minus 4 electrons producing 2H2O plus O2. This equation is very important and you need to memorize it because you will encounter it several times during the examples we are doing. At the cathode, well, we only have H+ ions as the cations, so it will be 2H+ plus 2 electrons producing H2. Now, this next example is electrolysis of concentrated hydrochloric acid. The ions present in the hydrochloric acid are H+ ions and Cl- ions. And from the water we have H+ and OH-. So the anode is positive and the cathode is negative. So at the anode we expect the negative ions to move towards it. So we have Cl minus and OH minus moving towards it. But because it is concentrated hydrochloric acid, the chloride ions are what are going to be discharged. And the half equation is 2Cl minus minus 2 electrons producing Cl2 gas. And at the cathode we have 2H plus 2 electrons producing H2. Now the ratio of gases in this case here is 1 to 1. Okay, in the example before with the sulfuric acid, we had 4 electrons in this half equation and we had 2 electrons here. If we want to write the overall reaction, we will have to balance the number of electrons. In order to do this, this second equation here, this one, has to be multiplied by 2. So we end up with 4H plus 4 electrons producing 2H2 gas. So therefore, for every 1 mole of oxygen produced, we will produce 2 moles of hydrogen gas. So the ratio of oxygen to hydrogen is 1 to 2. So whenever they ask you ratio of gases produced in electrolysis, just make sure you balance the number of electrons before making a statement. Now the electrolysis of very dilute sodium chloride. We have from the sodium chloride Na plus ions and Cl minus ions. And from the water we have H plus and OH minus. We are using graphite electrodes in this case. And at the anode is positive and the cathode is negative. At the anode, we expect the negative ions to move towards it. So we have Cl minus and OH minus moving towards it. But because we are dealing with very dilute sodium chloride, the OH minus is what is going to be discharged. So we saw this equation before. It is 4OH minus minus 4 electrons producing 2H2O plus O2. At the cathode, we have sodium ions and hydrogen ions moving towards it. But the hydrogen is what is displaced because hydrogen is lower down in the electrochemical series. So it'll be 2H plus 2 electrons producing H2 gas. And if we balance the electrons in this case, we get 4H plus 4 electrons producing 2H2. So therefore the ratio of oxygen to hydrogen is 1 to 2. Now, electrolysis of concentrated sodium chloride. We just did the electrolysis of very dilute sodium chloride. In this case, we have the ions present from the sodium chloride is, oh, that's a mistake. It should be Na plus and Cl minus. And from the water, we have H plus and OH minus. At the anode is positive and the cathode is negative. So at the anode, we expect the chloride ions and the OH minus ions to move towards it. Now, because we are dealing with concentrated sodium chloride, the chlorine or the chloride ions are being discharged. So the equation is 2Cl minus minus 2 electrons producing Cl2 gas. At the cathode, we have Na plus and H plus moving towards it. But in this case, the hydrogen is what is being discharged. And the reason for that is that hydrogen is below sodium in the electrochemical series. So it is 2H plus 2 electrons producing H2. The ratio of the gases, Cl2 to H2, in this case is 1 to 1 because the electrons are already balanced. Now, let's look at electrolysis of copper 2 sulfate. In this first instance, we are going to use carbon or graphite electrodes. From the copper sulfate, we have Cu2 plus and SO4 2 minus. And from the water, we have H plus and OH minus ions. Now, the aqueous copper 2 sulfate solution is blue. Okay, and the reason for this blue color is the presence of Cu2 plus aqueous copper 2 ions. Now what is going to happen is that the copper 2 ions are going to move towards the cathode, and copper is going to be deposited at the cathode. So as fast as the Cu2 plus ions are coming out of solution, the color begins to fade. So it may start off as a darkish blue and eventually fade as the copper is being deposited. So you're going to have pink copper or pinkish copper being deposited at the cathode. And so at the anode, the reaction is 4OH minus 4 electrons producing 2H2O plus O2. So the OH minus ions are discharged in preference to the sulfate ions. At the cathode, we have Cu2 plus from solution. Sorry, this is Cu2 plus from solution plus 2 electrons producing copper. Okay, so make sure you understand that the solution is initially blue, and the reason for the blue color is the presence of the Cu2 plus ions. And during the electrolysis process, copper ions are being converted into copper. So you will see a pink deposit of copper on the cathode, and because the Cu2 plus is moving out of solution, the color fades. And in our last example, we have copper 2 sulfate solution, but in this instance we are using copper electrodes. The copper electrodes in this instance are said to be active because they take part in the reaction. So from the copper 2 sulfate we have Cu2 plus and SO42 minus, and from the water we have H plus and OH minus ions. Now at the anode, what is happening is that the copper electrode is being converted into copper ions. Okay, now remember the anode is positive and the cathode is negative. So what is happening at the anode is that the SO42 minus and the OH minus ions are drifting towards it. However, the copper is being converted into Cu2 plus. So the half equation is Cu minus 2 electrons produces Cu2 plus. At the cathode, we have Cu2 plus again being converted into copper. So Cu2 plus 2 electrons produces copper. So again, the solution is blue, and that is because of the Cu2 plus Aq ions, and the copper ions, Cu2 plus ions, are being converted into pink copper at the cathode, but at the same time your copper anode is being converted into Cu2 plus ions. So as fast as copper Cu2 plus ions are being removed from the solution, it is being replaced by the anode. So what is happening here is that the anode is decreasing in mass, alright, and the solution, the blue solution, does not change color because as fast as the Cu2 plus is coming out of solution, more is being put back into the solution.